All right, I'm going to spend some time on this problem because I don't think anybody got it right. So let's read the problem. So we have two sets A and B. Each set has 3 elements. And we let C be A cross B. Now what is this C? What does A cross B mean? This is ordered pairs. And you can go back to the book in the function section. It talks about Cartesian product, which is the symbol cross here. Here it talks about ordered pairs. So the set R cross R is the set of ordered pairs where the first element is in R and the second element is in R. We want a general definition. We have any two sets. So here we go. Here's the definition for Cartesian product of A cross B. Ordered pairs, the first in the pair is in A and the second in the pair is in B. Right, so let's use that information to see what we want to do here. So you want to list the elements of C. So you want to list all ordered pairs. So first we need to well, everything is going to look like this. It's going to look like an element in A and with an element in B. So I can write C equals. Now let's just try to do this systematically. Let's first look at all elements in C such that the first element in the pair is 1. Okay, so I could have 1. Then what could be in the second one? Well, any one of 4, 5, and 6. So I have 1, 4, 1, 5, and 1, 6. All right, but that's not all. I also have elements that begin with 2. So I have 2, 4, 2, 5, 2, 6. Now you don't have to list them in this order, but I'm just trying to list them in a systematic way. And the first element could be 3. So I have 3, 4, 3, 5, and 3, 6. Okay. Now it should have 9 elements because the Cartesian product has 3 times 3 elements if there's 3 in the first set and 3 in the second set. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're good. That's the elements of C. All right, part B, prove or disprove that this is an equivalence relation. All right, there are 3 things to prove: reflexive, symmetric, and transitive. So let's look at reflexive. Reflexive means that any element must be related to itself. Now, what do elements look like? Elements look like an ordered pair. So the question is, does any ordered pair relate to itself? That's the question. Is this true? Well, let's see. 2 elements are related if A1 minus A2 equals B1 minus B2. Now, A1 minus A2 in this case is A minus A. B1 minus B2 in this case is also B minus B. And this is true. So that means it is reflexive. Okay, now see what I did here. I applied this relation to these 2 elements that I'm trying to see if they're related or not. Okay. So that's reflexive. Let's go down to symmetric. So in symmetric, you have 2 elements are related, and we can say this way: A1, B1 related to A2, B2. This should imply, and I'm going to put a question mark because I don't know if that's true or not, but this should imply that A2, B2 is related to A1, B1. All right, so the question is, does this relation imply the other relation? Well, A1, B1 related to A2, that means that A1 minus A2 is equal to, let's see, is it B1 minus B2 or B2 minus B1? I don't remember. B1 minus B2. Okay. So if this is true, does that imply, now I have to apply the relation with these 2. Now this is saying, don't get confused by the letters here. what this is saying is that the first entry here minus the first entry here must be equal to the first entry here minus the first entry here. So in order for A2, B2 to be equivalent to A1, B1, it must be true that A2 minus A1 is equal to B2 minus B1. So the question is, does this imply this? And the answer is, this is true. Why? Since you're just taking the negative of both sides. A2 minus A1 is the negative of A1 minus A2, and B2 minus B1 is the negative of B1 minus B2. Okay, since A1 minus A2 is equal to, and that is true, negative B1 minus B2. Okay, so this establishes that A2 minus A1 is equal to B2 minus B1. Let me just say that right here. A2 minus A1 equals B2 minus B1. So that's okay. So it is symmetric. All right, now how about reflexive? I'm sorry, transitive. Transitive, you have to start out with A1, B1 is related to A2, B2, and A2, B2 is related to A3, B3. And the question is, does that imply that A1, B1 is related to A3, B3? All right, so that's the question. Do these two facts imply that A1, B1 is related to A3, B3? All right, so let's go down a little bit. So this fact, what does this mean? This means that A1 minus A2 equals B1 minus B2. And this one says A2 minus A3 equals B2 minus B3. Now, if I take these two together and add these two, if I take this one and I add, oh, don't know what happened there. Let's see what happened. Right here. That's right here. Oops. All right, sorry for the momentary glitch there. I'm going to take these two and add them together. If I add these equalities, I'm going to get A1 minus A2 plus A2 minus A3. So I'm adding the left-hand sides, and that's equal to B1 minus B2 plus B2 minus B3. So what does that give me? If I do the algebra there, so that means that A1 minus A3 is equal to B1 minus B3. Now what does that mean? That's exactly the statement that A1, B1 is equivalent to A3, B3. Okay, now if you were doing this yourself, what you would do is you'd write down this statement here, which you know you want to prove, and show that you can obtain this statement from the two statements that you're given. All right, so that's the approach, and in fact it is reflexive, symmetric, and transitive, so it is an equivalence relation. Okay. Part C asks for the equivalence classes. And there's more than one way to do this. I'll do the one that's most straightforward, brute force. You want to find the elements that are equivalent. So remember that A1, B1 is equivalent to A2, B2 if and only if A1 minus A2 equals B1 minus B2. All right, so let's look at our elements one by one. Now, if you remember how I listed them, first I listed all the ones that begin with 1, then I listed all the ones that begin with 2, all the ones that begin with 3. All right, so let's start with 1, 4. What is 1, 4 equivalent to? Well, first of all, it is equivalent to itself. Now, is it equivalent to 1, 5? Well, A1 minus A2 is 0. B1 minus B2 is negative 1. So no, that doesn't work. Okay, is it equivalent to 1, 6? Well, again, A1 minus A2 is 0. B1 minus B2 is negative 2. That doesn't work either. All right, so let's look at the ones that begin with 2. All right, let's see, we have 2, 4. Well, A1 minus A2 is negative 1. B1 minus B2 is 0. That doesn't work. Look at 2, 5. A1 minus A2 is negative 1. B1 minus B2 is negative 1. That's good. How about 2, 6? A1 minus A2 is negative 1. B1 minus B2 is negative 2. That doesn't work. All right, now let's look at all the ones that begin with 3. We have 3, 4. A1 minus A2 negative 2. B1 minus B2 is 0. Doesn't work. Okay. A1 minus A2 is negative 2. B1 minus B2 is negative 1. Doesn't work. 3, 6. 3, 6 does work. So we have 1, 4 equivalent to 1, 4, 2, 5, and 3, 6. Now this looks like an awful lot of work, but remember, once you've found 2, 5, and 3, 6, you don't need to check those again. So let's go ahead and check the next one. Let's check what 1, 5 is equivalent to. Well, we know it's not equivalent to 1, 4. It's certainly equivalent to 1, 5. Now let's see if it's equivalent to 1, 6. Well, A1 minus A2 is 0. B1 minus B2 is negative 1. That doesn't work. All right, then we need to look at 2, 4. A1 minus A2 is negative 1. B1 minus B2 is 1. That doesn't work. 2, 5. Well, 2, 5 we already have the equivalence class, so we don't even need to check it. 2, 6. A1 minus A2 is negative 1. B1 minus B2 is negative 1. We're good. Okay, let's check the 3s. We have 3. Let's see, 3, 4. Minus A2 negative 2, and it's positive 1. That doesn't work. 3, 5. A1 minus A2 negative 2. This is 0, so that doesn't work. We don't need to check 3, 6 because it's already in the list. All right, so we've already taken care of 1, 2, 3, 4, 5. We've taken care of 5. We need 4 more. Okay, 1, 6. Let's see. It certainly doesn't work with 1, 4, and 1, 5. It does work with 1, 6. Let's see, does it work with 2, 4? Well, we can start doing this by, well, let's go ahead and do it. 2, 4. Does it work with 2, 4? 1 minus 2, negative 1. This doesn't work. 6 minus 4 is 2. That doesn't work. So 2, 5 is already in the list. 2, 6 is already in the list, so we don't check those. Then we have 3, 4. Okay, 1 minus 3, negative 2. 6 minus 4 is 2. Doesn't work. 3, 5. Let's see. 3, 5 is not in the list. Let's see. Does 3, 5 work? 1 minus 3, negative 2. 6 minus 5 is 1. That doesn't work. 3, 6 is already in the list. So 1, 6 is only equivalent to itself. Let's start with the 2's now. 2, let's see. Do I have 2, 4 in there? I guess not, so let's try 2, 4. It can't be 2, 5 or 2, 6. Let's see if there are any of the 3's work. So let's see if it works with 3, 4. 3, 4 doesn't work, but 3, 5 does. And I already have 3, 6. And of course I need 2, 4 as well. Okay. 2, 5 is already in the list. 2, 6 is already in the list. 3, 5 is in the list. 3, 6 is in the list. 3, 4 is not in the list, so 3, 4 must be equivalent to itself. So if I want to summarize what the equivalence classes are, there are 5 of them. So the equivalence classes are 1, 4, 2, 5, 3, 6. That's the first one. Second one is 1, 5, 2, 6. Third one is 1, 6. Fourth one is 2, 4, 3, 5. and the last one is 3, 4. And I should check and make sure that I have 9 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the end of my problem, and I've finished.